All right, let's talk about something truly incredible, our memory. We're going to dive into how we actually build, store, and pull up all those experiences that make us, well, us. And it all starts with a question I'm pretty sure you've asked yourself before.
I mean, it's a weird one, right? How does that even work? This little paradox, it actually gets right to the heart of what's going on in our brains. See, our memory isn't just some dusty old attic where we shove facts. Oh no, it's this incredibly dynamic, super complex, and yeah, sometimes really, really selective process.
Okay, so how does a fleeting moment, a sound, a sight, whatever, turn into something you can remember years down the road? Well, it all starts with a kind of blueprint for how a memory gets made.
And this is our roadmap for today. It's called the multi-store model, and it's a really fundamental idea. The easiest way to think about it, it's like an assembly line for your memories. Information comes in, it moves through a couple of key stages, and, fingers crossed, it comes out the other end as a permanent memory. So let's check out each stop on that line. First up, the journey starts at what we call sensory memory. Think of this as a constant, massive data dump from your senses. Everything you're seeing, hearing, feeling all at once. It's capturing an incredible amount of information. But here's the catch. It's super, super brief. We're talking fractions of a second. Most of it just vanishes into thin air, unless you actually pay attention to it.
Okay, but what if you do pay attention? Well, that little sensory snapshot gets a promotion. It moves on to short-term memory. This is basically your brain's scratch pad. It's where you're holding that phone number someone just told you, or the name of a person you literally just met. But just like a real notepad, it's got limited space, and that ink, it fades fast.
And that brings us to the final stop, the big one, long-term memory. So how do we get stuff here? Through things like rehearsal. Repeating that phone number over and over again in your head. That simple act is what transfers the info from that temporary scratch pad into the huge, permanent library of your mind, where it's ready to be pulled up later.
Now, that idea of short-term memory as just a simple waiting room, it's a bit outdated. Modern science has a much cooler take on it. We now see it as a much more active, much more powerful space. Think of it less like a waiting room and more like a mental workbench, where the real work is happening.
So, let me introduce you to working memory. This is like short-term memory 2.0. It's not just passively holding information anymore. It's actively working with it. It's your brain's CPU, constantly juggling different bits of information to, say, solve a problem or figure something out.
So how does this mental workbench actually work? Well, it's got a couple of specialized tools. First up is something called the phonological loop. This is literally that little voice in your head, your inner ear, that you use to repeat things to yourself. It's perfect for remembering a name, some directions, or those song lyrics from 20 years ago.
The next tool on the bench is the visual spatial sketchpad. And if the last one was your inner ear, this one is your inner eye. You know when you try to mentally picture how to rearrange the furniture in your living room? Or when you map out a route in your head before you leave the house? That's you using this sketchpad. It handles all that visual and spatial stuff.
And of course, every workshop needs a boss, right? Well, that's the central executive. This is the supervisor, the director of the whole show. It's the part of your brain that decides, okay, pay attention to this, not that. It pulls old info from your long-term memory when needed and coordinates the work of both your inner ear and your inner eye. It's the one in charge.
All right, so we've got a pretty good idea of how memories get filed away in that big long-term library. But what's actually on the shelves? As it turns out, there are different kinds of memories, all sorted into different categories.
The biggest split is between what we call explicit and implicit memory. Think of it this way. Explicit memories are the things you can consciously talk about. You can declare them, like, I remember my 10th birthday party. But implicit memories, those are the things you just do without even thinking about it. A perfect example is tying your shoes. You can do it in your sleep, but try explaining exactly how you do it step by step. It's surprisingly hard, right?
Let's dig into that a little bit more. So under that explicit umbrella, you've got episodic memories. Those are the personal episodes from your life, like your first day of school. Then you have semantic memories, which is just your general knowledge, like knowing that Paris is the capital of France. Now, over on the implicit side, the classic example is procedural memory. That's the muscle memory for skills like riding a bike. And just to round it out, there's another type of explicit memory called prospective memory. That's a fancy way of saying remembering to do stuff later, like grabbing milk on your way home.
Okay, We've covered the models, we've covered the different types. But what is a memory on a physical level? Like what is actually changing inside your brain when you learn something? To see that, we've got to zoom way, way in, down to the biological level.
It all comes down to a process with a kind of sciencey name, long-term potentiation, or LTP for short. Here's the deal. Every time you learn or remember something, a signal travels down a specific path between your brain cells, your neurons. What LTP does is strengthen that connection. With each use, that pathway gets stronger and more efficient. It's kind of like turning a faint little trail in the woods into a super smooth paved highway.
So before you learn something new, the connection between two neurons, that's called a synapse, it's just a regular old pathway. A signal can get through, sure, but it's nothing special. You can think of it as just a potential memory, waiting to happen. But then, with repeated use, that's our friend LTP kicking in, look what happens. The connection physically changes. It literally gets stronger, faster, and more sensitive. Now, the signal doesn't just pass through, it zips across with ease. And that strengthened connection, that is the physical, biological trace of a memory, carved right into your brain.
So when you really get how memories are formed, it's pretty powerful, isn't it? It means that by choosing what you pay attention to, by practicing and rehearsing what's important to you, by really engaging with the world, you are literally, physically, the architect of your own mind. You're shaping its very structure. So the only question left is, what memories are you going to choose to build?